Hello, everybody. Hey, this is going to be the video for review number 3 on week 1. Before we get to any of the new stuff, I just wanted to talk about the answers to 4, 5, and 6 on the week 1 review 2. So the answers are 0.80 meters per second squared, 5 meters per second final velocity in 25 seconds. So you can kind of look through that. And if you need to pause it, there you go. But if you look at the worksheet, if you guys look at the worksheet that is given in week 1 review number 3, you're going to see partway down into that first paragraph, you're going to see these 4 equations. These are known as the kinematic equations. Now, as we talked about earlier, we're going to see some of these values as being like delta x, and we could have delta v or delta t, and that sorts of things. Now, when it comes to delta x, that is really just the distance or the displacement. And again, technically, it is the displacement, but we're kind of viewing things as distance and displacement being the same thing because they're all going in the same direction. So if you would like, if you want to kind of put this in and have distance instead of delta x, you can do that. And you guys can see on your worksheet that I kind of gave you 2 columns. I gave you the first one with the delta x's and then the second column with the distances. But one of the key things that I'm going to go over here in a second is to realize which equations don't have a particular variable, and that is the third column, so the missing variable. So in the first equation, you don't have any acceleration, and in the second one, no distance, and the third one, no final velocity, and the fourth one, you have no time. And this is going to be a key to understanding how to do these problems. Now, again, as you see in the original paragraph, when we add distance to this sort of thing, it really complicates things because just by adding another variable, we have a lot more complexity, which is kind of why we have this. All right. So as you can see from the reading, one of the key things is to identify 3 variables that you know and the variable that you're missing. Okay. So those 3 variables are all the variables that we're going to be talking about. So we can start out with talking about distance and time and acceleration and the final velocity and the initial velocity. And essentially, that is it. Now, realize that we could have an x final and an x initial in here. And we could also say, average velocity, which is the one up there. Okay, so what we're going to really go do, and we're going to do the first 4 here, and we're going to see this as examples on how to do this. Okay, so now if you turn your attention to number 1, it says a woman starting at 2 meters per second increases her velocity to 4 meters per second in 8 seconds, and we want to calculate the average velocity. Okay, so now we want to identify all these things, and the first thing in the beginning, we don't know what this is, and we do know what the time is 8 seconds. And we don't know the acceleration, and the velocity final is 4, and the initial velocity is 2. And we're being asked, what is the average velocity? What is the average velocity? So now we can identify this, and this one is dealing with equation number 1. Okay, you can see here we have these various variables. Okay, now the second part of this question is going to ask about distance, but if we look here, we're looking for average velocity. Okay, so because we're looking for average velocity, in addition to these don't have average velocity. So we're going to want this equation, okay? And because we know the initial velocity and the final velocity, we are going to use that equation. So we're going to say average velocity is equal to v final plus v initial over 2. Now we can see that I kind of skipped this part for now, okay? But our final velocity is 4, and our initial velocity is 2, and we're going to divide that by 2. This is seconds. These are meters per second, meters per second. So we're going to have 4 plus 2 is 6 divided by 3, divided by 2, and 6 divided by 2 is going to give us 3. So 3.0 meters per second is equal to our average velocity. Okay, so that is the first part of number 1. And now we're going to go to the second part. It's like, what distance did we cover? Now, what we can do is now just say that the average velocity is equal to the distance divided by time. And now we know what this is now. We know that that's 3. We're looking for this, and the time is still going to be 2 seconds. And so we can identify that this is going to be 3 meters per second is equal to distance divided by 2. And now we're just going to solve for the displacement. So we're going to multiply both sides by 2. This side's going to cancel out. And 2 times 3 is 6. So we're going to have 6, and this was seconds. We can see that seconds cancel out, so we're going to be left with 6 meters, which is equal to the distance. Okay. Again, the hardest part of these problems are identifying which equation to use. And the key one in the first problem here was that the fact they were asking for average velocity, and the only equation here that has average velocity is going to be the first one. Okay, so that made that one a little bit easier. Okay, so I'm going to erase this, and we're going to look at problem number 2, and we're going to see how this goes. And here we're going to see kind of the strategy of finding 3 variables and the unknown to get the answer that we are looking for. Okay, so we also have average velocity down here. So when we read the second question, it says a car accelerates at 3 meters per second squared. Okay, so we know our acceleration, 3 meters per second squared. We know our time is 10 seconds. Okay, the initial velocity is 10 meters per second, and we want to calculate the final velocity. Okay. All right. So even though we don't know distance and we don't know the average velocity, they're not asking us or giving us this. Okay. So we basically have this. So we have 1, 2, 3 variables which are given, okay, or the knowns, and we have 1 unknown. And so now we want to try to identify which equation we're going to use. All right. So one of the key things to understanding this is to figure out which equation doesn't have a particular thing. So we can see that we don't have distance, okay? So we're not going to use equation number 1, we're not going to use equation number 3, and we're not going to use equation number 4 because they all don't have distances, which now leaves us with equation number 2. So now we can write out that equation, and we can say V final is equal to V initial plus AT, and again we're finding this. So this makes this one easy because we don't have to do any algebraic manipulation to get our final answer. It's kind of in the form that we want. Okay, so our initial velocity is 10 meters per second, plus our acceleration is 3 meters per second squared, times 10 seconds, okay? And so we can multiply 3 times 10 is 30. Now we can see that this seconds right there cancels out with one of those seconds, and it leaves us with meters per second plus 10 meters per second. 10 plus 30 is 40 meters per second, and that gives us our final velocity. Okay, and there you have the final velocity, and that is the answer to review, or the number 2 in review number 3. Okay, so let's move on, and we're going to do number 3. And number 3 says, bike starting at rest accelerates at 2 meters per second for a distance of 24 meters. Find the bike's final velocity. So again, I'm going to erase this, and we are going to set it up in the same way. Okay. And again, this setup here gives us all our variables, and then we can try to identify what those are. All right, so a bike starts at rest. So we know that the initial velocity is 0, okay? And it accelerates at 2 meters per second squared. And we do that for a distance of 24 meters. And they do not give us time, okay? And we're looking for the final velocity, and they don't give us average velocity, okay? So one of the key things here is we don't have time and we don't have average velocity. So we're not going to use equation number 1, and we are not going to use equation 3, and we're not going to use equation number 4 because t has this. So we are looking for this equation right here. So we have distance. So we are looking for this last equation because we're looking for final velocity, okay? So v final squared is equal to v initial squared plus 2ad. 2ad. Now remember, you're going to use a calculator, so don't get freaked out about the fact that you might have a number and it's squared. You're going to use your calculator to do that. Okay, so now we can plug in our numbers. We're looking for v final, okay? So that is what we're looking for. Now our initial velocity is 0, so that's going to go away, plus 2 times our acceleration, which is 2, times our distance, which is 24 meters, okay? So now we're going to have 2 times 2 is 4, times 24 is 96. So we're going to have 96 meters, okay? I'm sorry, 96. This is going to be meters per second squared. Meters times meters is meters squared over seconds squared. So we got 96 meters squared per second squared is equal to v final squared. Now, you guys, our answer is not 96, okay? Because we notice we've got a v final squared. So to get rid of the square, we're going to take the square root, okay? So if we take the square root of this side, we're just going to get v final. And if we take the square root of 96 meters squared per second squared, these are going to cancel out. And if we take the square root, of 96, we're going to get 9.8. When we round it, 9.79, whatever it might be. When we round it, it's going to be 9.8. The square root of meter squared is meters. The square root of second squared is seconds. So we're just going to get meters per second. Now, you might get a little confused with all those units being squared and then taking the square root. But if you think about what should the units of velocity squared be, okay, or what are the units of velocity once you get down to the end? And the units for velocity or speed are just meters per second. So if you kind of save that in the end, it's like, hey, my number was 9.8, and so my units are just going to be meters per second, okay? So that is our answer for number 3. Okay, you guys, we're almost done. And again, this definitely is a trickier thing, and the hardest part about this is actually figuring out which equation to use. Okay, so I'm going to erase this. You guys can kind of read ahead and figure out which equation that we're going to use. And all right, so it says a motorcycle accelerates from rest to 25 meters per second in 6.6 seconds. And we want to know how far that the car went, okay, or the motorcycle. So we have our distance. That's what we're looking for. Our time is 6.6 seconds. Our acceleration is, we do not know our acceleration. We know what our initial velocity is. So our initial velocity is 0, and we have 25 meters per second. We don't know the average velocity, and they do not give us the acceleration, okay, but they're asking for the distance. So now we look, and this can be a little confusing here, and I want to point out something on this first equation right up here. Now, they don't give us average velocity, but we can say distance over time is equal to v final plus v initial over 2, and that can become its own equation. So we're looking for 3. So do we know the distance? No. Do we know the time? Yes. Do we know the final velocity? Yes. Do we know the initial velocity? Yes. And obviously that's just 2. So in this case, we're going to use equation number 1, okay? And that can be a little bit tricky. All right, so we're going to move over here, and now we're going to say distance over time is equal to v final plus v initial over 2. And now we can kind of plug in our numbers. So this is what we're looking for. So we're going to have distance divided by 6.6 is equal to 25 plus 0 divided by 2. Okay, now this right here, okay, we can figure out, but in order to get rid of this 6.6, it's on the bottom being divided, we're going to multiply both sides by 6.6. This side's going to cancel out, and now we're going to have our distance. So we're going to have 25 plus 0 divided by 2. This is going to be 12.5 times 6.6, and we're going to have 82.5. So our distance here is 82.5 meters. All right. So that is the fourth example here. Now, you guys have plenty of examples on the back, and when you look at the end to questions 5, 6, 7, 8, 9, and 10, I believe, you're going to see in parentheses what the correct answer should be. Okay. I'm going to do another video. That talks about the step-by-step process on how to do questions 5, 6, 7, 8, etc. Okay, but that'll be tomorrow, so you can get the step-by-step. But for now, you're just going to see the answers at the end. So if you got it right, you're good. And if you didn't, then you might have messed up something sort of minor, or maybe it was more major. But you can look at the example on those on a later video, which will probably be the beginning of the next review, or it'll just be a separate video. Okay, ladies and gentlemen, I hope that helps, and good luck.